Hi guys. So today we're going to talk a little bit about probability. So the first thing is, what is probability? Probability is how likely something is to happen. Okay? How likely is it to happen? Many events cannot be predicted with certainty. The best we can do is say how likely they are to happen using the idea of probability. Now, before we talk about how to find probability, you need to understand the term sample space. Now, the sample space is the total number of possible outcomes. For instance, when you roll a die, there are 6 possible outcomes. You could get a 1, a 2, a 3, a 4, a 5, or a 6. When you have a deck of standard playing cards, the sample space is 52 because there are 52 different unique cards. Okay? Now, there are 2 types of probability. They sound very much the same, but they're slightly different. The first is theoretical probability. That's what is supposed to happen, okay? So theoretical probability is the number of ways it can happen over the total number of possible outcomes. And that comes from your sample space, okay? It's the size of your sample space. So the theoretical probability is the number of ways something can happen over the total of number of different possible outcomes. Now, the empirical probability, otherwise called the experimental probability, is what has actually happened when you did the experiment or when you actually flipped the coin or did whatever the activity was. The empirical or experimental probability is what actually happened over the total number of possible outcomes. Now, the complement of an event is everything in the sample space that is not that event. For instance, if when you're rolling a die, you want the probability of getting a 2, then the complement of that is the probability of getting anything other than a 2. That means a 1, 3, 4, 5, or 6. And the way we write that, if P of E is the probability of getting the event, then P of E raised to the C, that raised to the C means it's the complement, okay? So let's take a look at some simple probabilities here. First one, tossing a coin. When a coin is tossed, there are 2 possible outcomes. You can get a heads or you could get a tails. We say that the theoretical probability of the coin landing on a heads is 1/2. Okay, because when you toss it, there's 2 possible outcomes. That's my denominator. And I want a head. There's only one way I can get a head, so that's 1 out of 2. Also, the theoretical probability of the coin landing on a tails is also 1/2, because there's one way you can get a tail out of the 2 possible outcomes, heads or tails. Okay? Now, symbolically, how do we write this? This would be the probability of getting heads is 1/2, and the probability of getting a tails is 1/2. And that's how we write it in mathematical notation. Now, this is our theoretical probability because that is what is supposed to happen. All right, now in actuality, when we flip the coin, we might get 3 heads in a row rather than just getting having half our tries be heads and half be tails. Reality is sometimes different. That's why sometimes the experimental probability is slightly different than the theoretical or expected probability. Well, what about if we throw a dice? If we throw one die, then there are 6 possible outcomes. You can get a 1, a 2, a 3, a 4, a 5, or a 6. Okay, there's 6 sides on the die. The probability of getting any one of them, the probability of getting a 2 or the probability of getting a 5, is 1 out of those 6 outcomes. So in other words, the probability of getting a 5 is 1 out of 6 because only one of those numbers is a 5, and there's 6 possible numbers. Well, this P of 5 raised to the C, that's the probability of not getting a 5. Well, if I don't get a 5, I could get 1, 2, 3, 4, or 6. There are 5 numbers that are not 5 out of the 6 possibilities. Now, the one thing I want you to notice here, if I take the 1/6, which was the probability of 5, plus the probability of the complement of 5, which was 5/6, they add up to 6/6, which is 1. the probability of an event happening plus the probability of its complement has to be 1, because it either happens or it doesn't happen. That's a certainty. It either does happen or it doesn't happen, and that has to add up to a probability of 1. Let's try something different. Now we have a gumball machine that contains 5 different colors. There's 36 red, 45 white, 15 blue, 20 green, and 5 orange gumballs. The machine dispenser randomly selects 1 gumball. Well, before we do probability, we want to make sure we know the size of the sample space. That's how many gumballs there are altogether. So there's 36 red plus 44 white plus 15 blue plus 20 green plus 5 orange. And yes, you can pull out your handy dandy calculator. 36 and 44, that's 80. Then we've got 95, that's 100. And then we have 120. So there are 120 gumballs in the machine altogether. Okay. Now, what's the probability of getting a green gumball? Well, let's look back. There were 20 green gumballs, so 20 out of the total number of possible is 120. Now, here's the key. You must simplify. If we reduce 20 over 120, and you can put that right in your calculator or Desmos, hit enter, and that's going to reduce to 1 out of 6. So the probability of getting a green is 1 out of 6. Well, what's the probability of the complement of getting green? That would be the probability of not getting green. Well, that would be red, white, blue, and orange. And if I take away the green, that means there's 100 gumballs that are not green, and that's going to reduce to 5 out of 6. Now, if you remembered that the probability of green plus the probability of its complement has to be 1, you could have started with, okay, that's 1/6. 1 plus what will give me the denominator 6 and go right to 5/6, because remember, 1/6 plus how many 6 will give me a total of 1, which would have to be 6 out of 6, because the probability of an event plus the probability of its complement has to give you 1. And then we would be able to find that that's 5. All right, let's find the probability of orange. Well, if we look, there are 5 orange gumballs. So there are 5 orange gumballs out of 120 possible gumballs. And we can reduce that because 5 goes into 5 once and goes into 120 24 times. Now, what's the probability of not getting orange? Well, see this 1 over 24? Now, the neat thing here, if you know you want it to add up to 1, the shortcut here, take the denominator 24, subtract the numerator 1, and you get 23. 23 over that denominator 24. That would be your final answer. Now, you could have done it differently and said, okay, if I want the probability of not orange, I'm going to add up my 36 red, my 44 white, my 15 blue, and my 20 green. I'm going to have 115 gumballs out of 120 gumballs, and that's still going to reduce to 23 over 24. Either way you do it does not matter. Okay? So just remember that you have theoretical and experimental or empirical probability. So your theoretical probability is the number of ways something can happen over the total number of possible outcomes you have. The experimental probability is what has happened over the total number of possible outcomes. And the complement is the probability of something not happening. Okay, guys, have a good day, and I'll see you soon. Bye.